Let's talk about classes and objects. Working with classes and objects really just opens up our program ability that we can add into our different projects. And we can actually model things based on the real world. We can take a lot of those Excel spreadsheets and we can combine them or change them to be a class, and we can make objects off of that to hold data. Whenever we have a class, we get some methods that we can use with it so that we can make the class more functional. The class essentially is our blueprint, if you remember that from week one. So with a blueprint, those give us our instructions and all of our requirements for our objects, and then our objects themselves will be customized or have the characteristics that they need for each specific object. So, we have a blueprint for a house. We can make multiple houses off of that, but each house might be a little bit different. We might have different color siding, different roof color, but basically they all look the same and they all function the same because they're based off the same blueprint. Whenever we work with classes, you'll often see a class diagram, and I have some of those set up in our Blackboard course that you'll see next week whenever we start working with classes and objects. Each class has private data types or data. Those are the variables for the class. And those are, if you think of it in terms of like your Excel spreadsheet, those are going to be your column headers along the top that contain the information. And then each of the class will have public interfaces or methods with how we interact with the class. With object-oriented programming, is we keep the data private inside of the class so that it can only be manipulated or changed using the methods. This is a control tactic that lets us hide the implementation details, but still gives us the ability to work with and control our data for our programs. Whenever you're thinking about making a class, take time and think about, why do you need a class? What task will the class perform? How do I interact with the class? What kind of information do I need the class to have or to hold? Are there relationships between classes and other classes? What will the methods return? What kind of information will I get back? So this example in the table down here is a sample, maybe like a cash register, where we add items to a receipt. We can get the total amount, we can find out how many items were purchased, and then we can clear the cash register for a new sale. First thing we do is we look at our tasks, list out all of our tasks that we need, and we create our methods or start thinking about our methods, and then our return, like what kind of information will we get back from those methods. To create a class, essentially you need 5 things. A public class name, that's going to be the name of the class, that's how you're going to create objects from the class. Private instance variables, so those are going to be, again, like your headers in your spreadsheet. Those are going to be the data that the class that'll be the data that each object will be required to have or will need to have, can have. We need constructors. These let us create objects off of our class. We need what are called getters and setters. These let us get the values out of the instance variables and set values in the instance variables. And then we need helper methods. One of the most common helper method that we have is a toString, and our toString lets us just repeat the information that is inside of the private instance variables so that we can see what's been set, what hasn't been set. So each object that is created from a class has its own set of instance variables. So again, I know I keep saying it, if you think of it like a spreadsheet, you end up with these headers up here at the top. Look at my awesome, wow, my great Excel spreadsheet. This guy up here is going to be essentially our column title, and then this will be all of the objects that we would create off of the spreadsheet. So maybe the first one is name. Wow, that's beautiful. And let's say like phone number, ID number, and what else? Name, phone number, ID number, address, or something like that. So these would be, maybe these are employees, and these would be my instance variable, and then the data for employee 1, 2, 3, 4 would be contained inside of here. So these guys are going to be my my objects, and then this up here will be my class definition. So whenever you're creating instance variables, they have to have 3 things. They have to have an access specifier, or an access modifier, so that you know who and where can access those. In POJOs or plain old Java objects, our instance variables are always private. Right from the start, you'll get in the habit of creating your private instance variables. And they have to have a data type. What data type could name be in our class example up here? Yes, string. And then we have to have our private string, and then we have to have a good variable name. Again, these are going to be lowercase, and it's extremely important to use camel casing. In Java 2, you will find that if you don't use camel casing, that your string isn't going to work with your methods or your classes or persist your information to your database correctly. So this is why I keep harping on making sure that our methods and our variables use the proper camel casing so that things will work on down the road. So what would be, let's look at ID for a second. What do you think would be a good data type for ID? It could be int, or it could be a string, depends on the, what do I want to call it, the convention for the ID. So let's just use int for right now. So with ID, it could all be lowercase, like that. What about, let's see, address, that's probably going to be a string, and all lowercase. And I'm not going to deal with phone number right now, but that gives you some idea. So after you create your class, you will next put in your instance variables. Let's look at this next example. Here's an animal class that I've already thrown in here. And this one has 4 instance variables: type, name, weight, and int. And notice that they're all private. And then we have our public class animal. In theory, I should have probably put this in here, but here's going to be our curly bracket for opening the class. And down here will be our curly bracket for closing the class. So again, just a refresher with our private, what private means, that means that it's only available inside of this class. If I tried to use it in a reference animal in another class, and like cat, for example, if I was trying to reference age from here, since age is going to be private, I'm going to get an error. I'm not going to be able to access directly what's inside of that variable. Instead, I use what are called accessor methods, or getter methods is what you'll more commonly hear them called. But getter methods will let you get the values out of that variable. So we would use get age in order to get the value out of the cat object for that cat. Encapsulation allows us to have a public way to get inside of that instance variable, but it also hides the implementation details. So, you know, an age is just an integer. It's not that big of a deal to just see that information. But one thing that you can do to hide implementation details is, if you think about phone number for a second, you can think of multiple ways that you save or work with the phone number. Sometimes you'll have parentheses, sometimes just dashes. Well, your class can handle how it wants to save that phone number inside of the database. So maybe the setter for that will take all the dashes or the parentheses out, but whenever we use the getter, it may return it back to the user with those dashes or those parentheses. So it allows us to hide the implementation details so that the users don't necessarily need to know or deal with how that phone number is going to be formatted. They don't need to have the correct way to put the parentheses in, all that kind of stuff. We can hide all those details inside of our class, and the users won't know. So that's just one way that you can hide the implementation details that you're familiar with. So let's talk about those accessor or mutator methods. We are going to refer to them as getters and setters. Accessor methods are just going to get the information out of the instance variable and return it back to us. Normally, the return type for these methods are the same as the instance variable. So in this case, get total. Total was a private double total variable. So our method is going to return a double from that to get that information out of the instance variable. On the flip side, our mutator methods, our setter methods, are going to take a value and set that value for that instance variable in that class. The parameter for that mutator method or that setter method will be the same data type as the instance variable. So we will have, you know, private double price, or private double, price. Sorry, I'm blanking for a second. And that sets the price variable. This should be called differently. I don't know why I've named it like this now that I say this. These are more helper methods than they are setters. We might have a set total method that sets the total, or sets the item for that, but the setter methods are going to be the same return type, or excuse me, the same parameter as the instance variable data type. All right, let's talk about constructors. Constructors are ways that we can create instances of the object in another class. So inside of our class definition, we have to outline what our constructors are and what they and how to set the values for those instance variables. We have two kinds of constructors in Java. We have default no argument constructors, and we have non-default constructors. I know, such tricky naming conventions for POJOs. A default no arg constructor essentially creates an empty constructor or an empty object of the type. And I have another example. I'll show you this in just a moment. Now, all POJOs, plain old Java objects, have to have a default no arg constructor. Behind the scenes, whenever you are creating objects, or in this case, what are called entities, entities are components that have a special classification that allow us to save them to databases or to pass those objects around. We have to have a default no arg constructor. Because the first thing that it does whenever it returns information from the database or passes information to is it creates those objects as a plain old Java object with just an empty object, and then it fills in the details for each of the values in the instance variable. So we have to have a default no arg constructor in all of our Java classes. Now there's two ways we can do this. We can have an implicit or an explicit default no arg constructor. So what does that mean? An implicit one assumes one, but one is not specifically defined. So if you have no constructors listed in your class, you have one implicit default no arg constructor. It just doesn't show there, but it always has one. Now, if you have a non-default constructor, that means that that constructor overrides our default no arg constructor. You'll remember what overriding methods are from week 4, where we create the same method name, but they have different parameters going into it. So once we create a non-default constructor, then we have to add in our default no arg constructor so that we end up with 2. The default constructor takes no parameters and initializes all the instance variables to default values. So if we have a number, it's going to default those instance variables to 0 or 0.0. If we have a Boolean, it's going to initialize it to false. And we have any objects or strings, it will initialize it to null. So this guy right here is our default no argument constructor, no arguments as parameters into this constructor. We can have more than one constructor. We can have as many constructors as we need to work with our class. Each one just has to have a unique set of parameters. Again, that's something that you're familiar with from overloading methods. So here is my explicit default no arg animal constructor. And here's my second helpful constructor that takes in a string for type, and it would set that value for type that's being passed in through the constructor. And then it would default set all the other values to something else, either to their default value, or it might set it to another value that we have inside of our constructor. One error that will commonly happen is people will have the return type of their constructor set to void. And if you put a return type in your constructor, then you've no longer made it a constructor. It is now just a regular method with a return type of void. And one note, the compiler doesn't think this is an error, because this is just a regular old method now called animal. So it's not in, maybe this is intended to be a constructor, but this is not a constructor whenever we have a return type here. Whenever we're working with classes and objects, you can probably guess this, but at this point, we are working with more than one Java file. So our constructors are going to be in the Java class that are defined as that class, so public class animal. Our constructors are going to be used in a place to create objects from another class. So the example I have here is the public class animal tester, and that has a public static void main. Inside of that class is where we're going to create instances of animals, so tigers, lions, bears, oh my, all inside of that main method. We talked about overloading constructors, really cool. As long as they are have the same name, they can be overloaded. And again, they have to have different order, different number of parameters. So one, notice here's my default no argument, and then I have these non-default constructors, string, 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 int. And then I tried to create another one, which is string, but I can't do that because I already have one animal or one constructor that takes a string data type inside of it, so I can't create another one. Eclipse will complain about that. Some of the common helper methods that we'll use, we will put a toString in every class that we create. A toString is just going to report back what's set in each of those instance variables. So it just gives us a way to quickly see what's set. And that way, if we see something with a gaping hole, like maybe feline is gone, that will give us a hint that we forgot to set something or we're not getting it set correctly. Now, depending on what other methods you need to use your class, you can create as many helper methods as you need. So maybe this have birthday one will add another year to the age, lose weight, gain weight. Maybe that's helpful. So I must add a weight one in there. Forgot about it. But there are other helper methods that you can use too to work with those instance variables. Whenever we work or whenever we have Eclipse auto-generate our methods for us, our getters and setters, and our instance variables, excuse me, nope, they can't. Eclipse cannot generate our instance variables, but it can generate our constructors. You will see this reference. And what this reference is to show you that you are setting the variable for this object versus the parameter that's passed in. Eclipse will help us out with this. It will keep them different colors. So, but this just essentially means, hey, I'm setting this name for this animal and not the constructor. So our animal class has no main method. It's part of a bigger program. And we have a couple different ways that we can test our class. We can use unit testing, and I'll show you how to do that coming up with our course registration project. Or you can write a tester class with a main method. And then we can create objects inside of this and set instance variables and make sure that values are being set correctly and that the project is ready to roll, or that the class is ready to roll. When we create objects, we have to use the new constructor. You're familiar with this because you're used to using the scanner. Scanner in equals new scanner. Whenever you get ready to create an animal, it'll be animal with the local name equals new animal. These will go inside of our main method or inside of the tester, not inside of our class. So I shouldn't see a new object being created inside of your class yet. We will get to that with some methods, some helper methods that can create objects for us. One important note, I want to separate that model and the view. So we don't have sysouts in our class. If we're going to print from our class, we need to print inside of our main method. So they are helpful for testing though. If you're not sure if a value is being set correctly, you can do some sysouts maybe in a getter or setter or something like that, but just make sure that you comment them out because we want to keep them separate. We have a model view controller pattern that I want to just briefly talk about. 3 components: model, view, and then my controller. So our model is going to be like our class. It'll be our animal. It contains information about whatever kind of objects we're going to hold. Our view is how our user interacts with our class. So these are going to be like our console, our Java Swing, which we will start working with in a few weeks. And then, HTML pages, JSP pages, these are all different parts of our view. Now, our controller is our connection between the two. So what happens is our user will come in, interact with our view. So they'll come into our program, interact with our view, and maybe they'll type in their favorite animal. That information gets passed over to our controller, which will grab our information out of whatever view we're using. And then that controller will pass that information over to our animal or our model. And maybe it will create an object, and then maybe it will persist it. And if it persists fine, then it will pass back to the controller, hey, we're good to go. And the controller will pass over to the view whatever page it's supposed to load next. On the flip side, let's say that we got data over to our model, and maybe it's missing a component. Maybe it's missing a weight. So at that time, that animal will send over to the controller, hey, bad data, and the controller will say, okay, let me redirect them back to the starting page so that they can put in the information that is missing. And after it gets that information, then it passes it back over to the controller. So you can see the separation here between the different components. So all the user interaction is handled inside of our view. Our controller is there navigating for our user, figuring out where it needs to go based on feedback from our model, or from our model will be connected to our database as well. So kind of a relationship, the relationship between the MVC view pattern so that you can see the separation of the components. So we want to keep our sysouts in here inside of our main method because they should not be part of our class. Just a couple more examples, and then I'm going to talk real quick up through a tree problem. 2 examples, creating instances of objects. Here's our animal. This one's called penguin with our new keyword in the class name. Second one's called cat. Again, this is using our default no arg. This would be inside of our animal tester class with a main method. So it might look something like this. I have a new animal, I set the type to dog, and I could do dog to string, and that's going to print out all my information that's inside of my dog object. Tiger, this one is using the non-default. It's passing in the word tiger, which must go in for the type of the variable, and then we could sys out tiger to string to see what all was inside of those instance variables. So with tiger, the first value, the type will be set, but everything else will be set to be a default value. So zeros or false or nulls if they're strings. Let's talk real quick about this one. This would be like a tree object. This is a spreadsheet that I tossed together really quick. So I could use these guys up here as my instance variables. We've already done the hard work of creating our instance variables. They would all have the data type of, or not the data type, excuse me, the access modifier private. So our class might look something like this: public class tree, and it opens up into some parentheses. And then I'm going to have my instance variable. So I'll have my private string name, private string bark, and we did leaves with string as well. With leaf size, we decided either int or double. I'm just going to do int because it's shorter to type. And then this is where my camel casing comes into play here. So leaf size, capital S. And we have private. This one was a Boolean, and all lowercase. And then our zone, I'm just going to call it zone, but I could call it zone hardiness too, I guess. This was an int as well. I'm going to call it zone of hardiness. But we will next generate getters and setters. So I will have a getter for each instance variable and a setter for each instance variable. We'll have one getter for each instance variable, one setter for each instance variable. All right, then I will also generate a toString, which will just print out all the information inside of the instance variables. And then I will generate a default no arg constructor. It will look something like this. And then I will generate non-default constructors, which I have a lot of options on how many non-default constructors I have, because I'll have to decide what's the best case. Like, do I just really need one for name? Do I need one for all 6? Do I need one for 3 of the 6? But it will look something like this. I'm just going to do 2 of them, save time. And inside of here, it'll say this.name equals name, and this.bark equals bark. And then we will end up with this, with a, so we will have Eclipse generate our constructors for us. So this is essentially our class right now. Let's look at what a tree tester might look like. Now a tree tester is going to have these are where our different objects are going to come into play. So our tree tester, public class tree tester, and does my tree tester class, does it need a main method in it? What do you think? Yeah, you bet. So there's my abbreviation for my public static void main. And then I can create a tree. We'll call this one hackberry equals new tree. And if I can create it just like this. This is just using the non-default. And then I can use my setters that Eclipse will generate for me to set the name to be hackberry, to we'll set the bark. And I could use the rest of my setters, just the rest of those values. And once I was done, I could test it by doing a hackberry.toString. And this is going to print out all of those details inside of that hackberry. So right now it would just look like, you know, something like this inside of the console. We could create another tree by using our non-default constructors. So now I don't have to use my toStrings to set all those values. If I did, excuse me, not my toStrings, my setters. And then if I did red oak dot toString, in the console it'll print out something again that looks a little bit like name equals red oak, bark equals smooth, and then it would, you know, continue on from there. Leaf equals null, leaf size equals 0. So this is how we would create our objects, our tree. This is using the default no arg where we use the setters, and then this is using a non-default where we passed in values, which is pretty sweet. Next week during class, during our live session, I will have Eclipse open and I will show you the quick way to generate these. We'll probably generate 3 different classes and a couple of toStrings as well, and a couple of testers as well to play around with those so that you can see how quickly you can generate these classes and then work with them. It's fantastic.